So we looked previously in a video at these one-way flow restrictors, and when we are metering out, so putting the variable control on the exhaust of the cylinder, and that helps us maintain, I suppose, full power, full pressure. We're going to now just take a different approach and look at the system if we change the orientation of these flow restrictors. So if we decide to meter in, and we know we're metering in because that kind of arrow there is pointing in towards the cylinder. So I can rotate them around. Now what I'm going to do is I'm going to do this one at a time just to kind of show you. So if we meter in, and what I'm going to do is I'm going to meter in on this side, okay, so on the back side of the cylinder. So if we follow through when the valve gets activated, air is going to flow up this way. It's not going to be allowed in through this side because the ball and seal is going to be blocking it. So it's going to have to go through the flow restriction. So that means little air is going to be flowing in here, moving the cylinder forward. And what you will see is, you will see the cylinder slowly moving forward. Okay, so let's just see that happening. Okay, don't mind the error just because I haven't connected that other flow restrictor. So you'll see when I operate it, cylinder moves slowly forward and it returns. Now, you may say to yourself, well, you know, what is the real difference there? I had that turned the other way around and put it on this side when we metered out, and it did the exact same thing. Well, there actually is quite a difference, because what you're doing here is you're starving the cylinder as it's moving forward, and what you're doing is you're not giving it, it's not moving forward with full pressure. So previously we've seen that cylinder move forward with full pressure and then its speed being controlled, but watch, if you look at this, you see you don't get the thick blue lines coming up. So that means although the cylinder's moved forward slowly, it's moved forward with very little pressure behind it, so there's not much force that could, you know, actually move something. So what we're doing is we call that starving the cylinder and moving it forward ultimately with little pressure. So we're controlling the speed, but we're also limiting the pressure. So that really is what happens when you meter in, and that can be, you know, we can have a reason for that if needs be. Now on this particular student version, I don't have, I suppose, you know, a pressure gauge that I can just, you know, check the pressure and you could actually see that happening. But that is essentially, you can see it because thick blue lines means you have full pressure. You see you get full pressure coming in and you don't get that thick line coming out. Whereas when we did it the other way, if you check the other video, we have full pressure behind it. So that is the difference between metering in and metering out. We have that effect on pressure. Finally, the other thing just to have a look at is the quick exhaust valve is important, okay? So what I want to do is just bring in the quick exhaust valve, and what the quick exhaust valve is usually used for is if we want to retract the cylinder as quick as possible. So what I'm actually going to do is I'm going to rotate this around 180 degrees, go back to my meter out. So you'll see, just again, don't mind the error there because I haven't connected the quick exhaust valve. As we move forward, see that full thick blue line, we didn't have it fully thick up here, and then it's still, so we've maximum force behind it and we're restricting the speed. Now as that retracts, okay, so as that's coming back, I'll let it do its full sequence. Remember, we still have other parts of the sequence in there. When it's coming back, where we exhaust, and I suppose it happened really too quick there to see it, but we're not exhausting until down here. Okay, that's our nearest exhaust on the retraction of the cylinder, and that can cause problems for us in a sense, because if we wanted that to come back quicker, what we need to do is we need to bring in this, what we call this quick exhaust, which just basically gives us an exhaust earlier on, because this pipeline could be extremely long. Say if we're in a massive factory or along a assembly line, it could be a very long pipe tubing until it actually starts exhausting into the atmosphere, which can actually have an effect on the speed of our retraction. So if we want to just retract the cylinder as quick as possible, we usually put a quick exhaust on, because what that allows us to do, we can connect this up like that. It'll ultimately exhaust earlier, so it exhausts at this point in the circuit rather than down here. And although it doesn't look that, you know, like it makes that much difference in this short circuit, but in real life, if these tubings or these distances could be very long, you could see the effect on the cylinder. So you'll see again we've got our flow restricting going forward, but when it comes back we're just going to be exhausting here. Sorry about that. I'll play that again. So we're going to exhaust much earlier in the system, right in here, and it brings us back. So quick exhaust is very useful when you kind of want the cylinders to retract as quick as possible. And then we've got our flow restrictors that control airflow in one direction, and we have the meter in and meter out examples, and we've seen the kind of differences between them, how we can still control speed but also control pressure and force.